Hello viewers, good day to you all. You're welcome to today's class. I remain your tutor, Aisha Bande. Today we have a question to solve which is under empirical and molecular formula. A hydrocarbon with a vapor density of 29 contains a 2.76% of carbon and 17.24% of hydrogen. So we are asked to determine the empirical formula and as well the molecular formula of the hydrocarbon. So let's begin. For us to solve this question, or to solve any question under the empirical and molecular formula, the first thing we need to do as a first step is to bring out the elements that has been given from the question. So from this question, this is an hydrocarbon which contains both carbon and what hydrogen. This one has carbon and also has what hydrogen. So the mass of this from the hydrocarbon, the carbon contains is 2.76%. Okay, while the hydrogen contains 17.24%. Step is for us to divide by the atomic masses of each element, and carbon here we divide by 12, hydrogen we divide by 1. So from here we divide is 2.76 by 12, and this gives us a value of 6.89. While here we have 17.24 divided by 1 gives us the value of 17.24. Next step we take from here is to divide both values we have with the smallest number. Between 6.89 and 17.24, the smallest value here is 6.89. So we divide by 6.89 to the both sides. So we divide here by 6.89 and here also by 6.89. So this 6.89 divided by 6.89 gives us 1. And then here we have 17.24. We divide by the value 6.89. We're going to have approximately 2.5. Okay, so this 2.5 here, we're not allowed to approximate it to 3 as a whole number. What we do instead is to multiply, since the whole number here is 2, so we can multiply both sides by 2 so that we arrive at a whole number. So when we multiply by 2 here, we have 2, and 2.5 times 2 gives us a value of 5. Okay, so from here we can easily write the empirical formula, that is E, I call it EF. So the empirical formula now is going to be C, that is C. Carbon has a value of 2, and here we have hydrogen has a value of 5. So what this means is that the empirical formula is C2H5. Okay, so this is the answer to the first question, which is the empirical formula. So now let's get the molecular formula. For us to get the molecular formula, the relation we have to use to get this is, for us to get the molecular formula is going to be the empirical formula times N is equal to the molar mass that has been given from the question. Okay, so as you can see, we have our empirical formula to be C2H5, okay, times N is equals to the molar mass given in this question is the vapor density, which is given as 29. So from here we calculate the atomic mass of the compound here, which is C2H5. So this is going to be 12 times 2 plus that of hydrogen, which is 1 times 5, N equals to 29. Okay, so 12 times 2 gives us 24, then 1 times 5 gives us 5. All of these times N equals to 29. So we have 29N is equals to 29, and the value of N is equals to 1, because we get 1 because 29 divided by 29 is equals to 1. So what this means is that the value of N here is 1. So now we are going to substitute in the value of N here to get our molecular formula. So our molecular formula now is going to be C2H5N. So the N here is the 1, which is what we have here. So what this means is this one affects everything we have in the bracket, and then this still becomes C2 times 1 here is still 2, and here we have H, 5 times 1 is 5. So what this means is that the molecular formula also is C2H5. So for this question, both the empirical formula and the molecular formula is C2H5. So this is all we have on the empirical and molecular formula. We'll solve more examples in the next class. Thank you for watching, viewers. God bless you all, and bye for now.